Hi everybody, this is the last section in chapter 2, section 7. And again, we're going to continue with proofs in this section, and we're going to talk about more theorems about angles in this section. So again, I talked about earlier when we talked about theorems, I said that they would typically be written in conditional form or if-then form. And that conditional form is also the beginning of a proof. And when you have a proof, if it's written in conditional form, you're given, the problem that you're given to solve is always going to be the hypothesis, so the if part of it, and then what we want to prove is always going to be the conclusion, the then part. And we're going to look at different proofs today and some theorems. We're going to start off with complementary and supplementary angles. We'll also do a little bit with vertical angles as well. Okay, so our first theorem that we're going to look at is the equal complements theorem. And then you will see some people are divided in geometry. This book, when we do proofs, they will put the name of the theorem if it has a name. Otherwise, they'll write it out. Or you can write out what the theorem is. I am not picky either way. Now, when you work on my math lab, they'll have a specific way they want you to answer it. But again, so if I'm doing a theorem and I need to use my equal complements theorem for my reason, I can put equal complements theorem, or I could write out the words that describe it. So I could say complements of the same angle or of equal angles are equal in measure. And sometimes you may say, well, that's a lot of words to remember. It is, but the more you use it and the more you know the theorem, the words, it's not that hard to remember the words to it. And again, they don't have to be exactly the way it's worded, but as long as it makes sense, it's fine. So anyways, our equal complements theorem says that complements, remember complements are angles that add up to 90 degrees, of the same angle or of equal angles are equal in measure. So what they're saying here is, I know we have angle 1 and angle 2 equal 90 degrees, and angle 3 plus angle 2 equal 90 degrees. So 1 and 3 are both complementary to angle 2. So that means that 1 and 3 have to be equal to each other. Next up, we have the equal supplements theorem. It's the same thing as the complements, except now we're talking about supplementary angles. So here, supplements of the same angle, so again, angle pairs that add up to 180, or of equal angles, are equal in measure. So if I know that the measure of angle 1 is supplementary to the angle 2, and then I also know that 3 is supplementary to angle 2. That means because 1 and 3 are both supplementary to 2, that 1 and 3 have to be the same measure. They have to be equal to each other. Okay, so now what we're going to do is we're going to do a proof. And I apologize, I can't fit it all on one slide. But what we are given is that A and B are complementary angles. So we know A and B together add up to 90 degrees. We are also given that C and D are complementary angles, and that the measure of angle A is equal to the measure of angle C. So what they want us to do is they want us to prove that the measure of angle B is equal to the measure of angle D. So what we're going to do is we have the steps written out on the next page, and we're going to go through and put in our reasons. Okay, so we're going to do the proof, and I'm going to write it out. I thought I had the statements listed, but we're going to get the statements here, and then we're going to go from there working on the reasons. So we have our statements, and then we'll draw a line, and we're going going to have our reasons. All right, remember, statements, always your given you start with. And if you have different givens, you don't have to list them all together. So for the first one, we had two different givens. The first one said that angle A and angle B are complements. And then we also had angle C and angle D are complements. All right, and that was a given. And I'm going to leave that one separate from the other given that we had because it is the same. And then our other given is different from the first two, different type of information, but we know that the measure of angle A is equal to the measure of angle C, and that is also a given. And again, two different types of information, so I split them up. You could have probably put them all together, but I feel like if it's separate information, I split it up. Now, we got to figure out, what do we know? If I look at the first given, I know that A and B are complements and C and D are complements. But what does that mean? So if you say angles are complementary, I want you to think, what does that mean? Because in a proof, you have to tell me. You can't just say they're complements. What do we know about complementary angles? It means that they add up to 90 degrees. So what I can do here for step 3, which will help me, I can say, well, if they're complementary angles, then I know that the measure of angle A plus the measure of angle B equals 90 degrees because they're complements. I can do the same thing with C and D. So the measure of angle C plus the measure of angle D is equal to 90 degrees. And that is just our definition of complementary angles. And again, really what you want to think here is you don't want to assume that people know what complementary angles are. You have to put it in the proof. It's like later on we'll get a right angle. Like they'll tell us we have a right angle. But then one of the steps you have to say is, well, that right angle is equal to 90 degrees. Or if they say you have two right angles, you have to say they're congruent to each other through the definition. So you never want to assume that people know anything. You got to put it in there. Okay, so now I do know that the measure of angle A plus the measure of angle B equals 90 degrees. And I also know the measure of angle C plus the measure of angle D is equal to 90 degrees. So that means that I could, in step 4, say that the measure of angle A plus the measure of angle B equals the measure of angle C plus the measure of angle D. Now, do you guys know why? What do you think? What did we do in 3? We cut out, we had both statements, and they were both equal to 90 degrees, and we cut out the 90 degrees. So even though you want to say substitution, this is not substitution. This is our transitive property. We cut out the middleman. And let's see, step 5, because we're not to our proof yet. We had to prove that B is equal to D. Okay. Well, I do know that the measure of A is equal to the measure of C. And that's for my other given, and I haven't used that yet. So if I look at this line right here and I think about my given that A is equal to C, I can also do this. Well, I can say that the measure of angle A plus the measure of angle B is equal to the measure of angle A plus the measure of angle D. The reason I can do that is because I know A is equal to C. So what I did, what do you think my reason should be? Hopefully you said substitution, because I substituted A in for C. So that is my substitution. All right, and then from here, I can get down to, I can say that the measure of angle B equals the measure of angle D. And to go from this line to this one, I had to get rid of the measure of angle A. To do that, think of it like this. You're subtracting it from the equation. So my last step here would be the subtraction property of equality. And again, I know that you're not going to be perfect at this to start with. You're practicing, you're learning. So don't get frustrated. If you get parts of it, but not all of it, that is great. And again, the more we do these, the better you'll get. Chapter 4, we do a ton. You will be a rock star by the end of chapter 4. So don't stress. Keep practicing. Again, it's explaining your work. It's hard, but it's worth it in the end. Okay, now we're going to take a look at 2 more theorems. And the first theorem that we have is our linear pair theorem. And that says if 2 angles form a linear pair, then the angles are supplementary. And we've talked about this already. We're just putting a name to the theorem. We know if we have a straight line, it equals 180. So that means if you have a straight line, your angles are supplementary, and thus a linear pair will always be supplementary. Next, we have our vertical angles theorem, and we mentioned this when we talked about vertical angles, how vertical angles, each pair of vertical angles are always congruent. So, and that's what the vertical angles theorem says. It says that vertical angles are congruent. Okay, now we're going to do another proof, and we are going to prove, and this is going to be a short one, probably 4 steps, that vertical angles are congruent. So again, we're going to do our 2-column proof. We're going to start off with our statements. And then we'll have our reasons. All right, so we're going to start with our given first, and that is angle 1 and angle 3 are vertical angles. You can abbreviate, and that is our given. Okay, now we need to figure out how we can prove that angles 1 and 3 are congruent. And since we're proving the vertical angles theorem, we can't use the vertical angles theorem. But what we do know is we can use other theorems. And one thing that I always say to look for when we have lines is look for that straight line. Look for a linear pair. I do know that we have angles 2 and 3 form a linear pair. So I'm going to put that on there. So I'm going to say angle 2 and angle 3 form a linear pair. And then I also know to go along with that, which is the same thing. If I look here, I can say, well, I know that 1 and 2 form a linear pair. So I'm going to leave that. It's the same information. So I'm going to say angle 1 and angle 2. So you could have started step 3, or you could leave it because it's the same reason in step 2. And that would be just really your definition of linear pairs. linear pair. We'll add in there our angles. Okay. Now, we're going to go to step 3. And if I have linear pairs, then we want you to think, well, what do we know about linear pairs? And if we have linear pairs, that also means that our angles are supplementary. So we are going to say angle 1 and angle 2 are supplementary. Plus angle 3 and angle 2 are supplementary. Oops, I didn't write very good, but they are supplementary. All right, and the reason that I know the angles are supplementary is go back and look. We had that linear pair theorem where it said if you have a linear pair, your angles are supplementary. So my reason that I know this would be the linear pair theorem. And then I have angle 1 and angle 2 are supplementary. Angles 3 and angle 2 are supplementary. Think back to some formulas or theorems that we've talked about in the past. How can I prove that angle 1 is congruent to angle 3? And hopefully you remember we have our equal supplements theorem. It says if two angles are supplementary to the same angle, then they are congruent to each other. So my reason here to prove that angle 1 is congruent to angle 3 would be the equal supplements theorem. And this is why all vertical angles are congruent. We basically did a proof to figure out why they are congruent. Okay, just here briefly, I'm going to mention there are other types of proofs. I talked about them earlier. I said we would look at, we're going to do the 2-column proofs in the class, but there are paragraph proofs. It's another type of proof where basically you kind of put the statements and the reasons together. You write it out like a paragraph, like you're explaining yourself. We're not going to do any in class, but it's something you may see somewhere else. So I wanted you to be aware that there are paragraph proofs do exist. We have next our right angles congruent theorem. And this one, we don't use this a lot in some of our proofs. We will mainly talk about the definition of right angles where it says that they are equal to each other. Or if this is one time we would use this is if they give us 2 right angles, and they tell us we have 2 right angles, then we can say, well, those 2 right angles are congruent using the right angles congruent theorem. And again, in a proof, if they tell us we have 2 right angles, the next step that you should do should say those 2 angles are congruent, because we can't assume that people know that we have to write out all the steps, which I know sometimes gets tedious, but it's something we have to do. All right, so here is a proof, and it is written in paragraph form, so it's a good way to see just a paragraph form. They gave us the angles 1 and 2 are right angles, and they wanted us to prove that 1 was congruent to 2. So the paragraph proof, when you write it out, basically you can read it. It says angle 1 and angle 2 being right angles is given. By definition of right angles, the measure of angle 1 equals 90 degrees and the measure of angle 2 equals 90 degrees. Because we know all right angles equal 90 degrees. But then by transitive property, since both angles are equal to 90, it is true that the measure of angle 1 equals the measure of angle 2. But then we're talking about the measure here, and remember I said if you have the measure, then you have to go to the equals or the congruence if that's what you're proving. So the last step would be then angle 1 is congruent to angle 2 by the definition of congruent angles. So this is a good one to show they went from the measure, because they were talking about them being 90 degrees, to then once you get, say that these two are equal to each other, you have to just add one more step in and say, well, if they're equal, then they are also congruent. It is tricky, but again, I promise you we'll work through it. It'll be okay. Right, the last theorem that we're going to look at today in section 2.7 is the equal supplementary angles theorem. And basically, if you have two equal supplementary angles, they're going to be 90-degree angles. So two equal supplementary angles are always right angles. If you have two angles that are supplementary and the two angles are equal to each other, then they have to be equal to 90 degrees. So they have to be right angles. That's really what the equal supplementary angles theorem is saying. Right, and the last thing we're going to do is they want us to find the value of x. And this is using our vertical angles theorem. Anytime you have two lines that meet at a point, you should recognize, here's our two lines and they meet at a point. You should recognize vertical angles. So that, remember, opposite angles are congruent. So that means that this angle is congruent to this angle. So using our vertical angles theorem, that means that we have 5x is equal to 3x plus 33, and we just have to solve to find x. So I'm going to subtract 3x from both sides. We'll end up with 2x is equal to 33, and then we'll divide by 2. So I get x is going to be equal to, now I understand 33 is not a even number, so we're going to get a decimal. Or you could leave it as 33 over 2. Or you could say it is 16.5. Or you could have 16.5. Just really depends on how they ask for the answer. Sometimes on my math lab, they'll be picky and they'll say we want it as a fraction. We want it as a decimal. So you just have to kind of look and see what they ask for. But all three of these are equivalent answers and all three of them are correct. All right, that is it for chapter 2. Chapter 3 will be coming up shortly, and that will be, we will look at parallel and perpendicular lines.